Okay. So the first example that I want to talk about should make sense to everyone because you're all taking courses, but it's an aggregation example, meaning that we are going to have an object that has a field that's object, that has objects in it. So we, you're all in a course, right? And we have some things that go with a course. But one of the things that you have that go with a course is a course name. Okay. So with a course name, let's go to this course. Actually, yeah, here, let's go here. The course has a course name, and that's just a simple string that's going to be the course name. Now, it can also have like a section number and all of that, but we're just going to have it have a course name for now. Now, when we have a course, we have an instructor that teaches the course, and the instructor has information that goes with them. So we are actually going to count that instructor as an object, okay? So because the instructor is an object within the course, it looks a little different. So you can see that there's actually a data type that's instructor. So we're actually going to have a class that has all the setters and getters and fields for an instructor, everything that an instructor can do. And then we also are going to have a textbook, and textbook is also going to be its own object within the course object. So we're going to have a course object, and the course object is going to have a course name, which is a simple field, and then we're going to have aggregation. So we have an instructor object within the course and an actual textbook object within the course. So the instructor object, if you look at it, is going to have three fields, last name, first name, and an office number, okay? So, and of course, we could have more information. We could have phone number and all kind of other information, but we're just going to have that basic information. So these three pieces of data, these three fields, and everything is going to be private because we don't want people to be able to access and change things without going through the proper channel of setting those, okay? And so whenever you create an instructor, it's going to set the last name, first name, and office number as whatever you put in, okay? We're not going to worry about that right now. We'll come back to that. There is no way to create an instructor without having that information, without having the last name, first name, and office number. There's no empty one. So you will have to put that in there whenever you create an object. Okay, there's a setter. I'm not sure why I called that, I guess. Oh, never mind. We'll talk about that in a bit. We don't have a setter and a getter for each one of those. I probably should have one for the set name, get name, but y'all know how to do that. So you can add those later if you want to. But there is a toString, and the toString is going to return the last name, first name, and office number. So it does a little different because it has it in an str string and then it returns that, but you could just put the word return here and then have all of that there. That would also be the same. So if you ask about the instructor, like if you put the instructor object, then it's going to tell you last name, first name, and office number. Okay. Now, if you want to, that extra thing that I was talking about up here, you can do a copy of everything. So if you pass in an instructor, it will copy all their information into a new object. Let's take a look at the textbook, and then we'll come to the course, and maybe all this can kind of tie together. So the textbook has a title, author, and publisher, and a constructor matches the same name as the class. It's going to set all of those. Same thing, if you did want to pass in a textbook object, you could copy all the fields from there and save those. If you call the set, you can also pass in and save all of the different fields as well. There is no setter and getter for each one of them. There probably should be one for each field. But again, you can add those if you want. I think this is an example from the book. I think they took those out just because it was so much, because there's 3 fields in each, and that would give us 6 extra methods in each of these. And I guess they probably just wanted to focus on this part, but you could go back and add those because as is now, really don't have a way to change any of that information. If you don't have setters and you don't have any way to ask for an information. Now, you don't really need to ask about the information if you just use the toString, I guess, because you get all the information. So maybe you don't need the get because you can just use the toString to get that information. But you can't ask for just one piece of data, one field at this point because those are private. So just a heads up. This one is going to print the title, author, and publisher. Okay. And because you don't have getters, again, and normally you wouldn't use getters anyways, you just use the field names because they're within that class, so you can use the field names. And then here we have a course. And again, the course is probably the most confusing because the course has not only a course name, but has the objects within it. It has the instructor and has the textbook objects. So again, the name for that is aggregation. We say that the course has an instructor. So the has relationship is what is aggregation. It means that, you know, this object has objects within it, has fields that are objects. Okay, so this is an object, and then this is also an object. And so all that means is that this is going to have fields and methods and things you can do with it, and so is this one. Okay, so when you're doing it, one thing that we talked about the other day, I said that we would focus on more this week, would be that, you know, the course name's easy because it's just a string that we're saving. But when we're talking about the instructor in the textbook, we probably want to create new objects with it. And not link to the old one. Now, it's really up to you because remember I told you before that one of the problems with, you know, if you were to just send in this is going to reference whatever you're pointing to. And so if you actually make adjustments in there, it's going to change the original one. It's the same thing we were talking about with arrays. Whenever you send in an array, for example, you were just referencing an array, and if you happen to change that array, it actually physically changes the one that it was referencing. So it's the same thing here. If you put this variable here, INSTR for instructor, whenever you're actually doing it, like here, whenever you're creating a course, you're passing in this, which is created up here. You created the instructor up here, but what we're really doing is you're saying, I want to point to this object that I have, which is called my instructor. So I want to point to the my instructor object. So if you happen to make changes some point in your program with that one that you're referencing, it'll change it. And so you want to be careful with that because again, if you go and change like the first name of the instructor, then it updates everything because then you don't have an old reference to the old one because when you referenced it, you referenced the original. And so you change the original basically, which is okay if that's what you want to do, which sometimes that's what we want to do, but we don't always want to do that. So we have to know what we're doing. We have to know that the way that this is set up, we're not referencing the old one. We're taking the information from the instructor object and we're creating a new location for that so that we're not referencing the old one. Does that make sense? Otherwise, if I didn't care about that, I would just put INSTR in place of what I have highlighted, and it wouldn't create a new reference. I would just reference the old one. I would just say that the instructor in this one references the INSTR, and if I change that, then I change it and it changes the old one as well. So if I didn't care, I wanted it to do that way, I wouldn't put new instructor with the new one. I would just put the reference to the, I would just put this here, INSTR in place of this. Does that make sense? So this means don't reference the other one, create a new one, and then if I just put, again, is everybody following? That's fine to do, but just know what you're doing when you do that. Is everybody following? Oh, okay. You have to make a decision if you want that or don't want that, because of course it does take up, you know, more memory, more space and everything, or maybe you don't want it to actually function that way. Maybe you do want it to replace everything. So maybe that is what you're intending to do, but you just have to make sure that that was your intention, is to replace anything if you make changes. Okay, so same thing here. Do you want to reference the original textbook or do you want to create a new one so that if you make changes, it doesn't reference the other, it doesn't change the other one? So we call that a copy. And then what happens is whenever you do this, it's actually going to use the copy constructor. So if I say new instructor here, it's going to use this one because you see here that, whoops, let me go back. When I do this, I'm saying that I want to create an instructor, but I want to pass in an instructor. Does everybody see that? So it's going to take them, because how does it know how to create the new one? It's going to take this instructor and pass it here to this object 2, and then it's going to take all of the fields and put them in the new one. Yeah, okay. So here we are passing this whole object. So think like I have this instructor, okay, that has all these attributes, okay? And what I want to do is I want to take that, okay? Now I am referencing now, like object 2 is pointing to that instructor object, right? But I want to take the last name from this one that was being referenced and I want to save it into this new one. And then I want to take it and I want to save it into here. I'm taking each one out. So if you had 10 fields, you'd have to take each one and you'd have to save it over. So like, you know, you just have to be careful because it's easier to just point to it because then you don't have to take each field and copy it over. But if we wanted it to have a new one, we have to take each field and copy. So we have to take the objects that we're referencing, we have to take each field and save it into. Okay. Are y'all following? It's the same thing with the other one. So if you go back over here, when we create the textbook, we have the textbook one. Bless you. So when we create it, we are taking that text and we are sending it. I'm in the textbook, right? Okay, textbook. We are sending it to object 2. We're referencing it with object 2, and then we're taking each field and we're saving it into each of the fields that we have. So we're creating a new object, and then we're saving that in the new object name. Okay, so that creates the references to the old object, or that makes it so we're not referencing the old object. Okay, but we wouldn't need to do that if we were doing it like the way that I showed you last class. We wouldn't need to have a copy constructor. We would just actually see the object and then assign it to the old object, and it would just reference it. Kind of like we did with arrays, but unfortunately we when I talked about I think it's easier to understand with arrays for some reason, I'm not sure, so could be wrong. When I talked about when we had a list of numbers, right, we had an array, and then we said that the new array equals the other array, so that means take the array and assign it to the other one, but it didn't take each value from the array out and put it in the new one. It just said, point to this other array I have. So then I told you the problem with that. I said that was great because now I have 2 arrays that have the same values, right? But then I said what would be weird is if you went up to the copy machine and you made a copy and then you took the first copy and you wrote something on it and then the second copy had the same thing written on it. That would be weird, right? That would not be like if I made copies for all of you of what I had, it might be actually kind of good. And then I took notes, you would all get that, I guess. But you might want to make your own notes, right? Like you might want to write your own things. And if I write something on my copy, it shouldn't happen on all your copies. Although, you know, maybe that's a good thing, right? But usually that's not what we want. Like usually if I change this, I don't want to change the original. Like if that makes sense. Like if I change, and again, like thinking of it everyday real life situations, you need to think about if you're changing the original object, then you no longer have that original values that you had with that object. Like again, I think a good example was the name thing. Like if you had a different name before and then you change your name, if you just override everything with your new name, then you lose all references to your old name. Like everything, you know. So I was telling you the example of like when I first started here, I was here for a year and I was Wrigley. But if they just changed it to daily, anyone that came back and said, oh, I had Wrigley for that class, they'd be like, we don't know who that is. We don't have that in our system, right? Does that make sense? So that could be a problem. Could be good, could be a problem, right? It just depends on what you're doing. But you have to know which one you want to do. Like, do you want to create a copy of it or do you want to just change the other one? Okay, so and maybe for like textbook, you say, I just want to change it, right? You know, maybe. Okay, so here we're creating copies though, just to show you how that works, in case that is what you want to do. Now in here, we do have like a get name, so we can return the name. And this one is going to, oh, I have it in here. I have the getters in here. Okay. But we probably don't need the getters. I mean, we can, but we can use the toString. That's going to give everything to us. So down here, we have this toString. I want that to go away for a second. I'm in the course, so this is the toString for the course. But notice the toString for the course has the course name, which is the first thing. Then we have instructor, but notice that we don't have like the last name, first name, and office number, I believe. We don't have all that information in here. That's because that's specific to the instructor. And so if I put the name of the object, remember that automatically calls the toString method. So I don't have to say instructor.toString, although I could. It'll automatically call the toString. So if you have a toString in the instructor, which is here, then all of this automatically is going to come along with that instructor object and the course one, which is kind of cool because it'll print all of that information. And then the same thing here, when I say textbook, it's going to print all the information from the textbook toString, which is all this. So I should get 7 things printed. I should get the course name, then I should get everything from the instructor, which is 3 pieces of information, last name, first name, office number, and then I should get the information for the textbook with those 3 pieces. So I should have 7 lines altogether, where you can only see in the course I only actually have, looks like I have 3, but I have the 3 that go with the one, the 3 that go with the other, and then the other one. So if I run it, I should get that. I'll go ahead and show you that that works. So the first one's just the course name, and then I have the instructor information, which is 3 pieces, and then I have the textbook information, which is 3 pieces. I have more lines because they have a header, but the 3 pieces of data from the textbook, 3 from the course, or from the instructor, and then 1 from the course, right? So altogether, 7 pieces of data that I'm looking at. Okay, so how does that all come together? Well, over here in the main method, you have to create an instructor, okay, and you pass in the information for the instructor. Okay, and then you have to create a textbook, and the textbook has 3 pieces of information: the name, the publisher, the name, the author, and the publisher. And then we create the course. Now the course is a little different because of aggregation. So the course has a title, so that's the simple part, right? And then it has an object for the instructor, and then the object has the 3 fields that go with it. And then the textbook is the 3rd piece, and it has the 3 fields. And the reason why this one's a little more tricky, oh, and then you can print this calls the toString on the my course, which is this one that we created here. And again, you don't need to say .toString because automatically that's a given, and then that's what prints everything for us. But I think the most confusing part is this whole copy thing in this one, because you have to just like with arrays, you had to think about, like, you have to pull all the values out of the array. So when I'm sending in a reference to the object, you don't want to just point to the object because that causes problems with referencing. So you have to send in the object, and then you have to pull out the values and put them in, you know, your fields basically, because you don't want to reference the old one. And again, you just have to know if you should or shouldn't do that, like if that's how you want your program to work or not work. Okay, so does anybody have questions about the whole aggregation or the toString? There's no equals on this one, but the toString, is that making sense to everybody? Do you see the toString is a little more complicated for aggregation, but do you see how, like, the classes that are an object within the other one, if they have a toString, automatically that gets called when you use that object, and it kind of all comes together. And again, you could put it all in one, but it's nice because now you can ask for just the instructor information or just the publisher or all together. Okay. I have some more examples for you. So I like this one. I think this one's pretty cool. Look at this one, because we talked about enums the other day. So an enum is just an enumerated list. It's basically like a way to show people what the options are, so that they don't put things that aren't options. Okay, so if this is like the list of colors, then you have a list. Or if this is the days of the week, then you don't get like different spellings or things that don't exist in there. So I want to show you this one. Let me flip out. I have these various enums. So like this one is the car colors. So those are the options you have, and that's it. You have 4 car colors. Okay. And so you just have, when you do an enum, you just have to make sure it's saved in the class name as that has the same enum, and you just put your list. They're constant, so they all get capital letters when you're doing it. And then I have one that's for the car types. So there's an enum of car types. There's just 3 car types. And then You have the sports car. And so the sports car actually has these fields, but the fields are actually enums. Like the car type is that list that you saw before, and the car color is the list of colors you saw before. And then you have just a price, which is just a basic number. But when you do it, the only difference is, I mean, this looks the same. So when you pass in, you're just going to save it as the fields. But when you do it and you actually make a selection, you will choose from the list. Like you will say the car type and you'll have to pick one of the car types. So that's what the kind of the difference. So let me show you that actually, because I think that'll help with how it works. So if we go to the main, do you see here, like when you create your sports car, it's called your new car. Instead of just putting in Porsche there, you had to say car type, dot, and then you had to pick one from the list. And so you can't pick something that doesn't exist, basically. And then when you pick the color, you have to pick one of the colors that exist. But it's still just going to take this value. So we have like Porsche red and 100,000, right? And then this is still going to just send it here. So like it's going to send, you know, your Porsche red and 100,000 here, and that's going to save those as the fields. Okay, so the purpose of the enum is just to make sure we get like a valid thing from the list into, you know, our fields. So we don't get a car that doesn't exist or a color that doesn't exist. And so that makes sure you have valid data. And then this is all the same, get color, get price, get, and then we have a string. You can use this if you want to, or you can do like the decimal format. The string dot format, remember, you know, looks a little different because you put your variables at the end and then you use like the percent sign. So, you know, percent %F for decimals, percent %S for strings, if you want to do that. And so really it's just going to print out the make, the color, and the price. And so when you run it here, there's a little extra code here. Like it didn't just create the object and print it this time. So it has a car that's a Porsche red and 100,000. And then it's going to use the make of the car. So your new car is this here. The make would be the Porsche, right? It's going to take that and it's going to decide, okay, if it's a Porsche, your car was made in Germany. If it's a Ferrari, it was made in Italy. And if it's Jaguar, it was made in England. And then there's only the 3 options, so we shouldn't have a 4th option, basically. So, you know, you could have, you're actually asking it to figure out the make based on this, and there is a get make over here. So that returns the make of the car. So when you say this dot get make, that way if you decide to change this, then this should update and say it accordingly. So everything should update. So all this is going to do is say, because it's a Porsche, it's going to say it's your car was made in Germany. So I don't have anything else printed. So it's not going to tell us any of the information about it, but we do have a toString. So we should probably use the toString to say what the information is about the car. So we have this toString over here that does tell us the make, the color, and the price. So we should probably use that on the car. So then if maybe before I have it print that your car was made in Germany, maybe I should print the information for it. So you would just do, I'm the wrong language. We could do the name of the object, which is your new car, and it should use that toString on it. And so this will print the information because this is going to call the toString on that object. And the toString is saying, I want you to print all of this. And then it should tell me what make it is based on the get make method. Okay. So now I have all the information. And then I have that it was made in Germany. But I want to show you how you can change that. So first of all, I just want you to see what options you have. So you have the ability to ask for like the make. You could also ask the color, the price. So if you wanted to do like more switch statements or something, you could, but this one's based on the make, and that's what it prints out about the car, just to show you could do something like that. But if I wanted to change it, like here, this is the cool thing about enumerated types and using like an editor. If you put like car type and you put period, these are the choices you have. So like if I wanted, I could choose Ferrari, And then I would know that it should say that the car was made in Italy this time. And so it says made in Italy. If I wanted, I could change this, but I can't just change it to whatever I want. I have to pick something from the list. Like I can't just put in there cyan. That's not an option. So it stops like bad options for me getting there. I can't have a car that's cyan. That would be cool, but I can't have that. I have to pick one of the cars. But easily, I mean, I'm sure you're aware, if you do get a cyan option, you can go add it. So like you're like, oh, we got this new car. You could just add things to the list. And so then I could go in here and I could say, oh, now I can do it, right? But I can't do it if it's not an option, right? So that's what's nice about enumerated lists. It stops values that aren't supposed to be in there from getting in there. Okay. Okay, so, and when you look here, Java knows that you're using an enumerated list because up here, we're telling it that we're using this. And so if you try to pass in something, you know, that's not a car type, like if I just took off the car type.cyan, if you think you could just put cyan in there, it's not gonna let you do that either because it's not a car type. Because it's saying it has to be a car type. So if you try to just like go back and just put the color in there in quotes, it's not going to let that because it's going to say, oh, that's not a data type that I have. And so it has to be a data type that's listed in that car type class. Otherwise, it's not going to let you do it. So like if you were thinking like, okay, well, why do I have to even put car type here? You know, can I just put Ferrari? Well, that's not going to work because it has to be listed here because this tells it has to be one of those. Does that make sense to everybody? So it forces you to use a car type from that list, which is kind of cool because now you don't, again, just get random strings of data, like all spelled different ways and things that don't exist, right? Because, you know, I'm sure you could get multiple spellings of Ferrari and Porsche and, right? And now you know that that car and those colors actually exist. Does anybody have any questions about that? Yeah.
So for the enumerated list, is the data type only a string or?
No, you can use numbers if you want.
So it just put, let's say, what does it have to be a single type or?
Yeah.
Oh, okay, gotcha.
Okay. Everybody good? Okay. So I have another example for you. I'm going to show you. This is the stock one. This is the one that we had on the slides, but it was really hard to explain because I didn't have the code for it. But I do have the code for it. So we could think back to those slides when it was confusing, and hopefully this helps like clarify that. Because I think it's the same example you had on your slide. And so if you think about, this is aggregation again, your book has lots of aggregation examples, just because that was one of the main points of this chapter. But hopefully it's not too bad. So you have a stock, and a stock has a symbol, which is a string, and it has a share price. Okay. So this should be pretty easy because we're just, you know, going through. There are getters for this, so you can get the share price, the get symbol. The toString is just going to print those two pieces of information. Again, you don't really need to save to a string and return the string. You could just do return if you wanted to. So just, you know, I typically just do this, but this is from your book, so that's why, I mean, kind of saves a little bit, but you know, whatever you'd like to do. It's completely, what NetBeans is complaining about here is that overriding annotation. It's completely up to you if you want to put that on there because that comes in chapter 10. So if you don't have it, that's fine. If that's confusing, it'll just complain and that's okay. So it's not a syntax error though, so you can leave it off. If you don't want to put that because you're like, I haven't learned that yet, that's fine. Okay. So you can leave things yellow, just don't leave things red. Okay, yellow is just suggestions, and you don't have to go with every suggestion that it says. So you can just go with, you know, leave it the way you have it. That's fine. Okay, so then you have the stock purchase, and the stock purchase has a stock object within it. So like when you're purchasing a stock, you need to have the stock, and the stock has the symbol and the price per share. But then when you purchase it, you're going to say, what stock do you want? So it comes with those two fields. And then you're going to say, how many shares do you want? Okay. So then it's going to figure out how much it costs based on what stock you have and the price per share, and then how many shares you have. Okay. You could do this all in one and just have all the information in there. But it's nice because if you think about it, when you're purchasing, you're using the stock and it has things that go with it, and then you're using the price, how many shares you want. Okay, so let's go down here and kind of look at this. So we have a get cost. The cost is going to take the shares. The number of shares is within this. So you can just refer to it as shares because it's a field in this cost. But the price per share is going to be based on the stock object. So we have to use it from the other file. Okay, but because it's not we have to say what object we're using it with. Now, sometimes it's this, but we're actually going to use it as stock.get share price because it's coming from the other file. So the share price is coming from here. Here's the share price. Get share price is coming from here. So it's not within the current, like everything in here, oops, it's referred to as this. And you don't have to put it, it's optional. But if it's in the other one, then you'd have to refer to it as that object. Okay. And that object, how do we know what that is? It's up here. That's the object that you are using. Okay. That's the name that you created in here for that object. So stock is a field within here, but this method is within that field. So you're saying basically within this object that has the two fields and has all the methods, pull this method. Does that make sense? It's kind of hard because, again, it's an object within an object. So this object is within this object, okay? So the get share price isn't in here because it would be upset if I said this dot get share price because it's not in this class. It's in the other one. Okay. So we are using it within the other costs. Okay. Now, what else might be confusing? Let's see. Let's go back. Let's go here and just take a look at everything. So you would need to create a stock, and that stock would need to have a symbol and a price. Okay. Now, this is called XYZ company. Just to make it interesting, we are going to allow the user to type in how many shares they want to buy down here. So that's why we have this scanner. But here, we're going to tell you what the cost is of that so you know before you buy it. So that stock is currently this much per share. Now, how do we know like what we're talking about over here? Like how do we know what stock we're talking about? Because when you create the stock here, you are telling it what share price to print here, and then you're going to tell it what company here. Here, this share price is within this here, and so you just have to tell it what company, and then it'll print the share price. And so then you can figure out how many you want to buy, and then once you figure out how many you buy, you can create the stock purchase. The stock purchase means you have to have the company and then how many shares, which is what you just entered here for how many you wanted. Okay. So instead of just having the two objects created like I normally have, this is a little more interesting because you're entering how many shares you want based on the price, but it's nice to know the price before you enter how many shares you want. And that's why we just had this extra thing here that said how much it was. But we haven't created the purchase yet with that object and how many we wanted, but this is where you enter how many you want. And then this is going to tell you what you're working with. So over here, when you're talking about the stock, how do you know what stock? that is what you're putting here. That stock is coming from up here, the XYZ in 9.62. So this object is that here, that information there. Are y'all okay so far? I know aggregation kind of throws everything off. Okay, so then here, you can take in, now this is that tricky part, right? Because the first thing we're talking about is an object, right? So we're passing in an object when we do the constructor. So that object here is what we have here, XYZ company. And then this is just the number of shares. And the number of shares is what you just entered here. It's just this here. So if I enter 10, for example, that's just 10, right? But this is the information from up here. Is everybody with me? XYZ is coming from up there. Is that object up there? So then here, we can choose one of two things, right? We can either just do this. That's the basic way, right, to do it. And say, I just want to reference that original stock, right? And that's fine if that's what you want to happen. And then, of course, the number of shares just goes into the number of shares. But this is that, like what we were talking about with the array. Remember when we talked about we are just referencing the original. Now, maybe you want to do that because, you know, you just don't want to have to create a copy of it, or you think it works that way. But you have to be careful, because if you make changes to that stock, you're changing the original. And we know that stock prices change all the time. So it might be good to have a reference of what the old prices were for that stock. And if you're referencing and changing prices, then you won't only have the updated price. Does that make sense to everybody? Like, so that's a problem with it. Like if you're changing information about the objects that you're using that referencing, then you may not want to have a point to the original reference. Okay, so we can then do it like this. So where we create a reference to a new spot. So we're not changing the old one. Okay. So then when we do this, what's happening is you're telling it to pass in the stock object reference. Is everybody with me? So we passed in the stock object reference. We're taking the reference to it. So this is still the XYZ company because that's what was sent in. So like here, when you told it here, XYZ company, that was the reference, right? Pointing to the XYZ company, which is this information up here, right? So we're pointing to this information here. And here we're taking that pointer and we're sending it to this here. And we're saying, now I want object 2 to point to that XYZ company. And then I want to take that symbol and save it here. And I want to take that and save it there. For the new objects. Okay. Y'all okay? It takes some, like, it's what?
It makes sense. I mean, like, I get it and I lose it, and I'm like, oh, it makes sense.
Yes. I think, I don't know why symbols spelled like that, but that's bothering me. I must have just hit an extra character in there sometime. But I think, like always, the more examples you see, I think at this point, you're probably gonna, that's why I didn't want to have you type it. I just want you to have a bunch of examples. So we went and we did, there's a bunch in course notes, but then there's other ones that we did in class. I'm hoping that if you try to follow like go to the main method and try to follow like what's going on. Like when we call this constructor, where's it going? And then what's that constructor doing? I hope that'll help, like with all the pieces. And then as you do it, like as you try to do the assignment, now with the assignment, you don't actually have aggregations. So, but the reason why there's so many aggregation parts is because that's the most difficult part. I think like understanding the toString, does that make sense to everybody? The toString is not bad, and the equals hopefully isn't bad. The hardest thing about the equals, I know we haven't stressed it quite as hard, is that you need two objects. The one that's you're currently calling the method on, and then the one that you're passing in. And then and then you just have to go through all the fields that you think should tell you if it's equal and compare them to see if it's equal. So hopefully that part's not that bad. those are the two main parts that I want you to bring out of this, but I do want you to understand aggregation because it is something that you'll probably use because, again, not everything is as simple as just being the properties that go with one object, but that object may have objects within it. And a lot of times that's the case. But you may or may not care about those objects, and that's why it could be as simple as just being like if you had a course, maybe instead of having a course that has an instructor within it, you could just have a course that has the has all the information just all in one. That's how we started, right? We would have had a course and it has a name and it has an instructor and it has a textbook. But if you really think about it, those should be separate because like the instructor has pieces of information, and if you put it all in the course, you're just repeating that because if you have that instructor teaching multiple courses, then every course you have that instructor's teaching, you're just repeating their name, I know it's not that much, but their first, their last name, and their office number in each of those courses. Whereas if you set that aside and said, okay, this is an instructor object and here's the information, now when you say this course has that instructor, then you don't have to repeat any of that. So you see how like that could be inefficient if you were thinking of it as like course has instructor, but you just put all the instructor information in the course object. Then every course you have, like for example, I teach 6 courses. All of my information is repeated in all 6 of the courses that I teach. And the same thing with every instructor that's just like repeated data everywhere that doesn't need to, and it's easy to make a mistake because now if I'm entering the data here and I'm entering it again here 6 times, I'm likely to misspell a last name or misspell something or, but if you just put it in one place and see these are instructors that we have for our institution, and then these courses have these instructors, then it kind of makes sense. It's just the code that makes it work. But does it logically make sense as to why you would not put all the instructor information in the course? You would want to separate that and say like this is its own object, and then this has that object within it. And same thing with the textbook, because there's even more than what we have. Like there's a title, author, publisher, but we can even have more. Like how many pages does it have? There's more information you can add to it. And of course, there's more with the instructor as well. If you thought like there's way more information, like, okay, contact information for the instructor, you don't want to just keep adding that to every single thing. And that way, if that information changes, everybody with me? Kind of, sort of, maybe. Do you understand the idea? But maybe getting the syntax is the part we have to work on. But the efficiency of not repeating that makes sense, right? Like having the instructor as separate, having maybe not this one quite as much, but I think the instructor course one kind of gives you the why, like why we do this, because this one not so much. I mean, I feel like you could probably just do that in one, but I think the instructor one, because there's so much that goes with an instructor and there's so much that goes with a textbook that we just don't want to keep putting that information in the course. We want to have that separate. And it's kind of nice because remember in the course one we had the 2-string for the course, and then we had it for the instructor, so we could say, okay, this is the information about the instructor. We can get that information separately. Then if it were part of the course, we don't really have a way to pull it out unless we create separate methods for it, and then it's not as easy. It doesn't work as nicely. Yes, you can force it, but it doesn't work, and it's not as efficient. So now you just have to decide, should I copy all the information or should I just point to it? Okay. And it's the same decision you have to make with arrays. Like, does this array just point to the other array? Like, if I'm using a method and I'm passing in an array, should I copy all the values out of that array before I use it? Now, if you're just printing it, it doesn't matter, right? Because you're not changing it. But if you're actually going to change values of the array, you have to think, should I copy those values out or should I just leave it, point to them, and change the original? And that just depends on why you're doing and what you're doing, right? Usually you want to copy it, but sometimes you want to maybe replace it. Okay, does that make sense, everybody? All right. I'm trying to think. Oh, bear with me. I want to do a Kahoot with you and make sure this is all making sense. So, okay. So when we're doing this and we're doing the stock, it's not quite as noticeable because I think it makes more sense logically when you're talking about like a course, an instructor, and a textbook. It kind of makes sense that a course has an instructor, has a textbook. A stock purchase, having a stock in it and having how many shares maybe isn't quite as like realistic. But the nice thing about having them separate is the stock has the symbol and the share price, and the stock purchase has the stock with how many you want. But you can have multiple purchases where you use the same stock but have a different number of purchases. Like I might say one day I want to purchase Microsoft, I want to purchase 10 shares, and then maybe it goes down in price, and then I do it again the next day and I purchase 20 shares. So you're reusing the stock object information, which only comes with two things, the symbol and the price. But you are buying it, different number of shares each time. But yeah, I see what you're saying. Like, why have that? I think this one's like, you don't have to in a sense, but it's kind of nice. I don't think this one's as realistic as the other example, like to kind of show you why. I think they kind of force aggregation on this one. You don't really need to do it. So I don't necessarily like this one as much as the course one. But you can, like, if you think of it that way, you can have it separate, and that kind of keeps it nice. For having.
Stocks if it makes sense and like why would you have it? In the course and the instructor, it makes much more sense.
I think because we can all relate to that, is like having like, and there's more information with an instructor. Like when you're talking in it, more than the three pieces I had, you can think of like a bunch of things that I would put, that I put on my syllabus that I would put. And the instructor with the course is kind of nice because having it separate means you only have to update that one place, and now they all are accessing the same information. And so with this one, I don't know. I mean, you only have a symbol and a price. And then you're only adding one extra thing. You're adding the number of shares. So technically, I don't know if you want to have like stock purchase object. I could see how you could just have a stock object and you could just ask how many shares and you could just multiply that times you could just use, I don't know. I mean, I think they kind of pushed it a bit. I don't know if like, but it's just another example. Like, could you do it without having the stock purchase object? Yes. Like, but with the course one, I don't think it would be as efficient. Like I wouldn't eliminate the instructor or the textbook. I would leave those as objects, but I think you could do away with the stock purchase object and not have, but I think they were trying to just say like, okay, the stock purchase requires the stock, and so the stock is the object within it. And we do have an equals that I just found that notice. I was going to do it with you actually, but we have one on here and it should be on your copy hopefully as well. And the stock just checks that two stocks are equal. So with the equals, you always have to have a second object you're passing in because you always have to have something to compare it because you're really just trying to see, is this object the same as the other object? Like, are these the same object? And so, you really, I mean, you can't compare just the price because some stocks have the same price, right? You probably just need to compare the symbols. I don't think you can have two stocks with the same symbol, but I mean, then you wouldn't know I don't know why you need to compare the price. I think you would just need to compare the symbol, but I guess it doesn't hurt like to have them both. But just make sure when you're doing the equals, because I know we haven't done this as much. If you're comparing things that are strings, they have to use equals written out. I know we don't think of strings as objects. We're going to talk about them more in chapter 9, like more in depth and learn like how they work. But strings are objects, like chars and ints and doubles and floats and booleans. Those are all primitives. They use equal. But strings use equals because they're more complicated because they have more letters, they have more characters, they have to go through every. So you have to use the equals when you're comparing like the symbol because it's a string, which, just make sure you don't use equal because then it won't work. Okay. And then equal for the price because it's a double, so it works. I think it'll warn you, but you may not pay attention because this happens a lot. And that's why I say that. Just make sure you don't do this. It should warn me though. I think it'll say something. Oh wait. Symbol dot equal. Did I mess something up? Yeah, it tells me comparing strings. No, I don't want to use equal equal. The string equal equal. I think I'm missing a parenthesis. Delete it one. Okay. So see how it lets me do it, but that's not good. But it does, I think it does warn me over here. I wonder if it'll fix it for me. No, I don't think it's gonna fix it. Let's see. Oh, it does tell me I should use equals maybe. That's one of the options. I think normally it'll come up with a light bulb, but if you don't pay attention, it could happen. And if you do this, then if they're, happen to be the same memory location, then it'll work. But if not, it won't. So sometimes you luck out, but usually not. So you need to make sure you do equals, not equal equal with strings, because Java doesn't give you a syntax error. So just be careful. And then equals equals. And then if they're true, and a lot of times, as before, I said that it is possible to just do this. But a lot of times you'll see people not do this because you could forget, like you could do this and then not have this. That's fine. It cuts down on your code. But if you don't have the else, or if you word it in a different way, like if this was an else if, then it would tell you don't have a return. So it just has to make sure you have, like when you're doing or something that returns, like a method that returns, this one returns a Boolean. So it has to return true or false. If Java sees that you have conditions that are returning and you don't have like an else on there, or you don't have a switch statement that has a default that has a return, or you don't have one at the very bottom that has return, true or false, then it'll tell you it's possible to get through those without having a return. So it'll say missing return statement. And you might say, no, it's not possible because I looked at all the situations. But the only way that Java thinks that it's going to be safe is if it has an else, or it has a default, or it has one outside of the conditionals at the bottom that's like a default one. That's the only way it's going to let you go. Because I know students say, I have a bunch of returns. What's it talking about? Well, if they're not one that will definitely happen, like being an else or default or outside, then it's not going to let you go. And if you remember to put the else and stuff, this is fine. You don't have to do like the Boolean variable. You could do that. Just make sure you have an else that's going to return. Or you do it the other way and you have like something outside that returns it. So either way is fine. That's fine. And I know it wants to flip this. I don't know if you logically like this better, but it wants to flip this. It's more condensed, but that might be more confusing. It's saying you don't need to have the if, because when this comes back, this is either going to equate to true or false, and then it's going to return what it equates to. So you don't have to say if and say return this. You can just say, okay, when you figure this out, if it's true, it'll return true. And if not, you don't have to say if it's true, return true. So, just like before, I think I was telling you, like, you don't have to say, like, if this equal true, you could just say if this, and that means if it's true. So it's kind of a little less code, if that makes sense. So sometimes you can always look at the hints it gives you and see if you like it. And if you don't, put it back. You can always undo. You like that better. So whatever way works. Did that help? Okay, good. I'm glad we have an equals. I was going to do it, but we have it, so we're good.
Just the stocks and make sense to me, but the code makes sense the way we do it, but just like why are we having stocks here, like two things, but with the course it makes sense to visualize it.
Yeah, I think it was kind of forced in this one. Like, I don't think it was necessary.
Course and structure for this, but that would make more sense.
Yeah, I like that one. I think like can save it, I guess. I think that just, and because we all have courses with the instructors and textbook, that makes more sense than the stock. So yeah, and then the course one, I don't think I do have an equals, but you can go add it to each of these if you want. So like each one would have, like the instructor would have an equals if you wanted to compare instructors and textbooks. And maybe you don't want to. Maybe you only want to have one for the course to compare if the courses are the same. You can do that as well. It's up to you. Like what do you want to compare? Like sometimes you might not want to compare the two items, so you don't need an equals if you want to compare them. But if you want to compare them individually, you can put one in each of the classes, like one for course, one for instructor, and one for textbook. You can go ahead and try that later if anyone wants to. Like if you try that and it doesn't work, let me know and we can take a look at it. That might be good practice to see if you can get that in there to see if the equals is making sense, because we haven't spent as much time writing it as the two string probably. But Let me know if it doesn't work for you and you have questions about it. Hold on just a second. I'm gonna pull up the Kahoot. All right, so let's see how it's making sense. Okay, let's talk about this. So assume the bank account class has been created and the following statements correctly creates the instance of the class. Okay, so we have this bank account. It has 5,000 in there. Assume like that's how much we have in the bank account. And then we want to print out account. So that's automatically should call the toString, right? So it should print the information. So I don't know if the word implicitly confused anyone, but again, whenever you put the name of the object, it should automatically or implicitly call the toString. Sometimes the wording is confusing, but it should call the toString method. Does that make sense to everybody? Okay. Okay, guys. So the Java virtual machine, sometimes called the JVM, periodically performs this process, which removes unreferenced object from memory. I didn't spend a whole lot of time. This was just in the slides kind of talked about. If you were referencing something and then you pointed it to somewhere else and it was left not referenced, what would happen? It's called garbage collection that automatically frees up the resources. Java does this automatically, so you don't have to do it. Whenever it feels that there's a bunch of things out there that are unreferenced, it'll go clean them so you have more room. Some of the programming languages, like C++, you have to do it yourself manually, but in Java, it does it for you. So garbage collection, but you don't have to do it because it does it for you. Hopefully y'all know this because we did quite a few examples of this just today. Okay, good. Aggregation. So making an instance of one class field in another class is called aggregation. So we call it a has-a relationship. So we say that this object has this other object within it. Okay. Um, Oops, sorry guys. I want to bring up an example. Okay, so when something is static, we say that it doesn't go with an object. So like if a method is static, it's not being used on an object. If a field is static, it's not being used on objects. What that means is if you had a class that was a blueprint for creating objects and you had fields that were non-static, every time you create an object, they all have those fields, right? So like we had this example of, and I don't think I saved it, but we had this example, I can do it again real quick. We have this example of the circle, and because that field up there is non-static, because if you don't write the word static, it's automatically non-static, then that goes with each circle we create. Each circle we create has a diameter, right? So if you create a static field, remember we talked about this, and I apparently didn't save it, but I said if you created a static field to keep track of how many circles you have, so like if you're keeping track, it would be an integer, but we would say int counter, something like that, then we would see that this does not go with each circle. That's just one field, or that's just the field, and you don't have multiple copies of it. It goes with the class, not with the objects. Okay, and the purpose was so that we can count how many circles we had. So then we talked about, okay, well, how do we know when we create a circle? Well, every time you create a circle, you know that it calls the constructor, right? And because we only have one constructor, we knew that we could put the code in there to increment our counter, right? Well, we also know that the counter automatically starts at 0, but if you feel like you want to say it starts at 0, you can do that. But it's automatically, everything is initialized at 0 with your fields that you have, and so you don't have to do that. But we said that we could add something like this in here to say that we know we have one more circle. And then when we wanted to see how many circles we had, because it's private, we had to create another method to access it. But if it wasn't private, we could just say so let me take this off here for a second so you can maybe understand how to access a static field. Okay, so over here, when we wanted to know how many circles we had, I don't need that for now. I just want to know that I have 2 circles, right? So if I did something like this, and I put like number of circles, and because it's a public field right now, I can actually just put, it's a static field, so it doesn't go with an object, right? So I wouldn't say, I can't say like C dot, what was the name of it? Counter. I can't say like C dot counter. And I'm hoping that this makes sense if I want to bring it up, because the counter doesn't go with the C object, nor does it go with like the C2 object. So what does it go with? It goes with the circle class. And why? Because it's a static field. So if it makes sense, because each circle shouldn't have its own counter, right? Because if you had 2 circles, this circle had a counter and this circle had a counter, and they were separate fields for each of them, they wouldn't, it wouldn't keep track. Like this one would say 1 and this one would say 1. It wouldn't say 2. I just need one field that goes with the class that gets incremented that isn't unique for each circle. Does that make sense? That is only for the class. And so this one field. So when we're talking about here, this question, we're saying when a field is declared as static, there will be only one copy of the field in memory. There's not a copy for each object or anything like that. There's only one copy of it. And that's what the static means, is that there's only one copy. And again, the reason for that is that we want it to just have that one value. Like when I increment it, I don't want it to have one for this object and one for this object. It goes with the class and it only has one value. Now, it's nice because I made it public so I can access it this way. But I did tell you, again, making it public leaves vulnerability for you to not only access it, but to change, like, access is a problem, right? But not only to print it, but you can change it. You can, because if I can do this, I can also change it. And so I always tell you, I want your fields to be private. And then you would have to unfortunately create a public method to access it called like, now when you're creating a public method to access it, this method, because it's getting the counter, would also be static. Because we're talking about the counter field that we're accessing. So we would have like get counter, and we want to return an int. Get counter, and it would just return the counter variable. And then that way, then that way I could have this be private. Because if I have this be private and I don't have this, I think it did give me an error. I didn't wait for it to do it, but I think when I made this private, it shouldn't let me do it. It might be, okay, it takes a second. It says it has private access, and so I have to add this at that point. Just because I don't like to leave that alone public like that, because it leaves a lot of vulnerabilities. And I know we're not a security class or anything like that. I can't say this anymore, and I have to say get counter. But I feel like it's good to teach you proper ways to try to keep things secure, the easy way. I mean, there's much more that we can do, but this is a basic, easy way that we can keep things a little more secure and get things to go through the proper channel instead of like letting anyone have access to everything and anything. So then I can't just say that, which again, I know it's easier to make things public because then you can access them easier, but it leaves it open for problems. And so it should say 2, and then it should change. Like if I delete one, I should say I just have 1 circle. Does that make sense, everybody? So that field only has the 1 value, everybody. So if it didn't make sense, does it make sense now? I know we just covered that one time, so we'll kind of review that. I thought I had saved that, so I didn't need to type it again, but that maybe it's good. We had to type it again. This is a hard one about static, so hopefully that made sense. So think about this one. It's a little tricky. Okay, so we got a variety of answers. So let's talk about this. So this one's tricky. So if you have a public static method named get number of employees, an employee class, and an employee object named employee1, I gave you that extra information, but you don't really need to know the name of the object because this is that same thing we're talking about with the circle. If you're talking about a static method, then it doesn't matter what the name of the object is because the static methods don't go with objects, they go with the class. So if you're trying to access a method that's static, you need to know the name of the class, not the name of the object. So you would say the name of the class, which is the employee class, and then the name of the method. So remember, static means goes with the class, non-static means goes with the object. So if I was accessing a non-static method, then I would need my employee1 object. But if I'm accessing a static method, then I'm just going to go to the class, not the object. Just like I just did with that circle one. Remember the difference is that if I'm talking about a method that I'm trying to access that's static, because remember this, we're talking about a field that's static that doesn't go with the circles. So this method is static because it doesn't go with like a particular circle. Like it wouldn't make sense for me to ask for the counter, but have to specify what circle first. Like, oh, you want to know how many circles? What circle do you want to know how many circles with? Like that doesn't make sense because when we're asking how many circles, it doesn't go with a particular circle, right? If I was counting like the number of students in the class, right? I wouldn't need to know which student to know how many students. Like I wouldn't need to ask like how many students or which student do you want to do that on? That wouldn't go. I would just need the class to know how many. So like if I'm talking about students and I had a student class, I would have to put students like the class and then get how many students, not like a particular student, then get how many students. Does that make sense to everybody? So kind of think of it, if you can in real world situations. Like if you're talking about static, because I know static is a hard word, static means goes with a class, whether you're talking about a field or a method. Okay. Also, non-static means that we're going with an object. So the opposite, like you have to have an object in order to do it. Okay, so this method is static again because it's going with a static field, and you do not need an object to know how many circles you have. Now, do you need to create objects in order to have a counter? Yeah, otherwise it'll be 0. Like if I take off all the circles, it won't have any. Like, but that's okay. Like I don't need to create circles to do it. I could still say, which class am I talking about? Talking about the circle class. I want to access this. Now, what will it be? Well, I didn't create any circles, so it'll be 0. But I don't need to create an object in order to access this. Now, if I want it to say something other than 0, then I'll need to create objects. But I do not need to create any objects in order to use this method. So it'll just keep telling me 0. But it won't give me a syntax error because I don't need to. So I'm saying the name of the class, which is circle, and then the name of the method. But if I wanted to use set diameter, I would say the name of the object, then set diameter. And if that makes sense, because I can't set the diameter of a circle without having a circle. So if you try to use like set diameter, just to kind of make sure this all makes sense to everybody, if I'm trying to set the diameter, I can't just say set diameter to 5 because Java would be like, what? Like, what am I setting the diameter of? And then you say, oh, I'm setting the whole circle class to diameter 5. No, you can't. There is no way to like do that, by the way. You can't say, I want to set all circle. Well, there is, but not this way. You can't say like the name of the class, set diameter 5, and it just sorts every circle that you ever insert in there to 5. Like that's just not how the code works. You can set all circles to 5, but you wouldn't do it this way. This doesn't make sense because you're telling Java you want to go to the circle class and you want to use the set diameter, but this is not a static method. So it doesn't belong to the circle class, it belongs to an object. So Java's telling you, no, that's not a class, that should be an object, right? Does that make sense, everybody? Like based on what you set up over here, if the word static there, then this needs to be a class. If the word static's not there, then this needs to be an object. And I don't have a circle object right now, so I can't do anything, right? I can't set the diameter if I don't create a circle object. So I would have to go up here and say circle C equals, and this is where I would say new circle, and I would say whatever I want to create it with to start with, and then I can change it down there. Does that make sense? Now that I have an object, I can change it. Are y'all okay with static? I know we talked about static methods, but static fields are kind of the same, but they're a little more confusing, I guess. So is everybody with me? Do you understand that question? Pretty? Okay. Because I know we had split answers. Just making sure it makes sense now. It was a tough question. Okay, good job, guys. So this is the same as array. So an enum with oak, maple, and pine. The ordinal value is like what, how do you pull like, starting counting? It starts counting at 0. So if you wanted to pull maple, it would be 1 because it goes 0, 1, 2. So ordinal might have tricked you a little bit, but it's just the index value, the same as you use for an array. So in ordinal means like in order, like what. Like if I wanted to pull maple, what index value would that be? Does that make sense to everybody? Sorry about the wording. That might not have been the best wording. Okay, last question. Okay. I know we do, but I just don't know where. Okay, we have to. Okay, guys, we got a variety of answers. So looking at the following declaration, which statement defines a variable of this type and initializes it with a valid value? Okay, so we have this enum with all these colors in it. If we want to actually create a color and save it in a color, so you have to create an object of the data type, the name that you gave the enum. So you would actually say like color dot and this, or I mean color and then a name for it, like my color, and then you say color dot which are the ones you wanted. So if you just want to use it like to print out, or you just say color dot and then it has to be one of the choice selections. But if you actually want to save it for later, you have to save it in object with the data type that's the same name as the class for the enum. I know we didn't really do that. So the last option is that. Does that make sense to everybody? Anybody have any questions about any of those? All right, let's see how we did. Okay, guys, good job. Okay, I'm gonna stop this.